Welcome. Today we're going to work on our second final review. It's our review again. There are 17 problems and we are going to roll through them. So let's start with number 1. All right, we're given a rectangular prism, this box, and we need to find the expression that represents the volume. So our volume formula, got to get that down first, is length times width times height. So it doesn't matter which you label as which, but one of these is my length, one will be my width, and one is going to be my height. And I just need to multiply these guys together. So I'm going to write it out, showing that they're being multiplied by using my parentheses. Let's say we're going to have x plus 5 times x minus 4 times x minus 2. It does not matter which order you multiply these in, as long as you multiply them. All right, so for me, in my classes, I like to talk about multiplying the last two guys first. So we need to focus on x minus 4 times x minus 2. We're going to FOIL it. So let's rewrite this. V equals x plus 5 times, now we'll FOIL. That's going to give me x squared minus 2x minus 4x. Negative 4 times negative 2 is positive 8. Okay. Now, some people like to go from here, and I've seen this on many students' tests. They start now distributing into these 4 terms. That's technically not wrong, but there's a lot of opportunities to make mistakes here. The faster, more efficient way of doing this problem is once you get these 4 terms on the right, is combine your like terms. In the next step, we'll write x plus 5 times, let's combine our like terms, it's going to be x squared minus 6x plus 8. So negative 2x minus 4x give me minus 6x. This is easier because now I only have to distribute to 3 terms, but we've got to do it very carefully. So next step, volume equals, so I'm distributing my x. X times x squared gives me x cubed minus 6x squared, that was from this, plus 8x. Okay, now we're going to distribute the bottom term, or from the bottom. 5 times x squared is plus 5x squared minus 30x, and finally plus 40. Now we'll combine our like terms for our final answer. So we've got volume equals x cubed. I have minus 6x squared plus 5x squared. That's minus 1x squared. And then I've got plus 8x minus 30x. That's minus 22x. And then finally, all by itself, I have a constant term, plus 40. And this represents our final answer, our polynomial expression for the volume. So we multiply each of these measurements. We focus on 2 of them first, and we FOIL. And then combining our like terms, we finally FOIL in our last, our third term. Okay, let's go to number 2. Given the polynomials, determine the number of zeros. So if you know what that means, then this is a very easy problem. The number of zeros from a polynomial is equal to the degree of the polynomial. Degree is just a fancy way of saying the highest exponent. Okay. So in A, we have an x cubed function. We have a cubic function. So my degree is 3. We have a degree 3 polynomial, so this is going to have 3 zeros. In part B, this is a degree 2 polynomial. Our highest exponent is 2. So this guy will give us 2 zeros. In our final example, we have a degree 5 polynomial. This expression is going to have 5 zeros, or 5 potential x-intercepts. Great. So that one's easy. Look for the highest exponent. All right, number 3. Graph this polynomial. So we need to list the zeros of the function. First things first, 0 is another way of saying x-intercepts. And the way we find our x-intercepts is we set the function equal to 0. That's how we always find our x-intercepts. So I'm going to rewrite my function. It's -2 parentheses x plus 3, x squared plus x minus 12, and I'm going to set that equal to 0 and solve for x now. Well, this isn't actually fully factored yet. We have to look over here. If I want to find my x-intercepts, I need to be in fully factored form. So I'm going to copy down what I got in the beginning. And notice I'm not distributing the -2. Because if I want to find my zeros, I want to keep it in factored form. I want this to be all by itself. Now I'm going to use magic x to factor this trinomial. So I need two numbers that multiply to -12 and add up to that positive one in the middle. That will be 4 and -3. So I get x plus 4 and x minus 3, and all that equal to 0. Now that it's fully factored, I can see that my zeros, there's going to be 3 of them. One from here, that's going to be an x equals -3. One from here, that's x equals -4. And another at x equals +3. Notice that I didn't get any x-intercept from this factor here because there's no x. If there was an x, then I would set that equal to 0 and get another 0 at x equals 0. However, since there is no x there, we do not get a fourth x-intercept. That -2 out in front is not going to give us another x-intercept. Just keep that in mind. Okay? Only if you see an x there. So these are my 3 zeros. I've listed them. This is the answer to part A. Now we're going to use these x-intercepts as part of C because it says sketch the graph. So our first step in sketching the graph is going to be to plot our x-intercepts. So we have at -3 an x-intercept, at -4, 0 an x-intercept, and at +3 we have an x-intercept. Now, different teachers teach this different ways. For my class, we look at the leading sign, and that tells us how our graph behaves at the rightmost interval. So on the right, my graph is going to behave according to this leading sign, which is negative. So on the right, my graph is negative. Hint, that means below the axis. So my graph looks like this. Now at 3, at x equals 3, my graph is either going to cross and become positive, or it's going to bounce off and stay negative. The way we determine that is we look at the exponent at x equals 3. So this is where I got x equals 3 from. I'm looking back over here. I'm focused over here right now. I got x equals 3 from this factor, and it has an exponent, an invisible exponent of 1. If I have an odd exponent or an odd multiplicity, that means that you are going to flip the sign, or other teachers say you're going to cross the axis. If I have an even multiplicity or an even exponent, that means you're going to keep the sign, or other teachers say you're going to bounce off the axis. Well, at x equals 3, I have an exponent of 1, which is odd. That means I'm going to flip this sign, so it's going to go from negative. Now in this interval, it's going to become positive. Hint, that means I'm crossing the axis. That's what's happening right now. Okay, at x equals -3 now. So you got to look where you got x equals -3 from. That's right here. I got it from this factor. And it also has an exponent of 1, which is odd. So I'm going to flip my sign again. So for this interval now, I'm going to be negative. So I flipped from positive to negative again. At -4 now, I have a decision to make. This is where I got x equals -4. It's from this factor. It also has a multiplicity of 1, which is odd, so we flip again. So it's going to be positive at the end. So using these negatives and positives, it helps me determine the way my graph, if my graph is above or below the axis. So I'm starting below the axis. I hit the x-intercept. Now, in this interval, I'm positive. That means I'm above the axis. Now in this highlighted interval, I'm negative. So I'm below the axis, so it dips down. It crosses. And at -4, I cross again. And I end up positive just like that. So your graph should look like this, like a downward snake. All right, number 4. Oh, I didn't finish. End behavior. So examining our graph, we see that as x approaches positive infinity, that's over here on the right endpoint, our graph is going down forever. That means that y is approaching negative infinity. That's my right end behavior. On the left side, this is where negative infinity is. As x approaches negative infinity, my graph on the left is going up forever. So we say y is approaching positive infinity. And that's our end behavior. Another way that you can determine end behavior is examine our original function. Notice we have an x to the power of 1 with an x squared. When we multiply that out, we get an x cubed function, and we have that negative out in front. So see if you remember, negative x cubed always take this downward shaping snake graph. All right, let's go to number 4. So we're going to do the same thing as we did in the previous problem. We're going to start by first finding our x-intercepts. So we'll set the function, which is x times x minus 1 times x plus 2 whole squared. We'll set that equal to 0. Now from that, we get 1, 2, 3 different zeros. We get x-intercepts at x equals 0, at x equals 1, and at x equals -2. Let's go ahead and fill in our invisible exponents right now so we know our multiplicities. For our first factor, we get x to the power of 1. This is also an invisible exponent of 1, and then this one is obviously filled in at 2. Okay, so let's plot our x-intercepts. 1 at x equals 0, at x equals 1, and at x equals -2. So starting on the right, this time we're beginning positive because there's no sign out in front. That implies that there's a positive. Now at x equals 1, so we're looking here, look above it. What's our exponent? Our exponent is odd, and odd means flip or cross the axis. So I'm going to become negative as I move to the left. At x equals 0, look over here, look at your exponent. Again, odd, so we're flipping again. And finally, at x equals -2, I have a decision to make. So look up. Our exponent is even. Evens mean keep your sign, or basically bounce, right? So we're going to keep that positive. And there we go. Now we're just going to connect our graph. So we're starting positive. We're above the axis. Hit the x-intercept. Now it says to go negative, so we need to cross down below, just like that. We're going to be positive between these two values. And right here, we're only bouncing because we're not going to cross and become negative because it says positive. That means be above the axis. And that's what our graph will look like. So let's state the end behavior now. At the rightmost endpoint, as x approaches positive infinity, y is also approaching positive infinity because it's going up forever. And on the left, as x approaches negative infinity, my graph is also going up forever, so y approaches positive infinity. And there you go. Another way you could determine the end behavior, again, is look at the x's. We have x to the 1, this is x to the 1, and this is really x squared. So if you take x times x squared, this is an x to the fourth function, that's positive. So you know its shape is like an upward opening W. All right, let's go to number 5. Okay, so given this graph, it says determine the domain and the range. So here's the interesting thing about this graph. Usually, when we're looking at parabolas, they go on forever and ever. Not this graph. We have to be careful because on this exam, these graphs have endpoints actually. So our domain for parabolas is usually negative infinity to positive infinity. Not this time. So let's take some notes. Our domain, we're talking about the x values, and we always read from left to right. So our domain in this case is all the x values that this graph takes from left to right. Well, this graph begins right here. So that x value is at 0. And reading to the right, it goes all the way from 0 until 6. And that's where it ends. So this graph exists for all the x values from 0 to 6. And that's our domain. For range, we're talking about y values. And we read from bottom to top. That looks a little weird. That's okay. So we read from low to high. So for this function, our range, we need to look at, so from the bottom, what's the lowest y value that this graph takes? Well, it begins here at a y value of 0, because it doesn't go below, right? If it went down to here, then that would be a y value of -1. But it does not extend below the axis. So it starts at y equals 0, and you can see that it exists all the way up until this y value of 9. So our range is from 0 to 9. It's how high does it go, or what are the y values that are covered. So these would be our answers for the domain and for the range. Next question wants the coordinates of the vertex. So our vertex is this guy. It's the peak, the max, or the min. And our coordinates are, well, it's going to be an x comma y. So our x value is 3, and our y value is 9. So our vertex, I'll write it a little more neatly. Our vertex is going to be 3, 9, and that's a maximum for this parabola since it's facing down. This is the highest point. Number 6. All right, given the following functions, we have f, we have q. It wants us to find q of f of 1. So this problem looks confusing. All right, thanks. Okay, so this problem looks confusing, but it's actually pretty simple if you know how to begin. So what we need to do, circle the inside guy. We need to find the inside first. It's going to make our life much easier. So go off to the side and go ahead and find what f of 1 is. Well, so let me write in red. We're finding f of 1 first. F of 1, that just means, hey, take 1 and plug it into your f function. So f of 1 is going to be 2 times 1 plus 2, which is 2 plus 2, which is 4. So if f of 1 equals 4, that means that I can now replace it. Instead of finding q of f of 1, I'm really just looking for q of 4. So we actually are replacing f of 1 with its value, which is 4. Now it's a much easier problem. I just need to find what's q of 4. So take 4, and now we're plugging that into our q function. Well, q of 4 is just going to be 4 squared minus 4 minus 5. That's 16 minus 4 minus 5, which is 7. Easy as that. So again, here's the trick. For these problems, you're going to find the inside guy first. That's what we did right over here. And then cross that out and replace it with the value that you actually found. So I went and plugged 4 in, and now I was just finding Q of 4. Number 7 says find the sum. Actually, it doesn't say find the sum. Let me write that down. So this question does not say find the sum. It does not want you to actually do the addition problem. All it wants you to find is the common denominator that you would use. Well, in this instance, I have x plus 2, which is a binomial. I have x minus 4. I'm putting parentheses around them because this plus sign here and this minus sign, they both act like glue. So these two terms got to stick together. Okay, they're a single factor. These two terms got to stick together. They're a single factor. Well, since these denominators have no factors in common, right? X plus 2 is different from x minus 4. Then our common denominator is simply the product of the two. It's just multiply them together. And that's it. That's our answer. The common denominator would be x plus 2 times x minus 4. So for example, if I said here, let's consider this a different problem. In this case, the least common denominator, again, these plus and minus signs are acting like glue, so you got to keep those together. Since these are different, they're not the same, we just multiply them together to find our least common denominator. Just another example. Number 8. List at least 3 possible solutions to the inequality. So if I want a solution, right, a solution is just a value of x that, that satisfies the inequality. That just means that when you plug it in, it makes it true. Let me give you an example. Let's try x equals 0 and see if that satisfies our inequality. So I'm going to just try some values, see if they work or not. So if x equals 0, that means I'm multiplying 3 times 0, and I'm subtracting 4 from that. Let's see what happens. 3 times 0 is 0. 0 minus 4 is negative 4. So the absolute value of negative 4, remember it takes any negatives and turns them into positive, is 4. So now I'm left with this statement at the end. Is 4 really greater than 9? No, that's false. That doesn't make sense. That's like saying 2 equals 5. Okay, that's false. That means, and I'll do it in a different color. Since this is a false statement, x equals 0 is not a solution. Okay, it didn't satisfy our inequality. It didn't make a true statement. Let's try a different one. Let's try now x equals 10. If x equals 10, and I'm multiplying 3 times 10 and subtracting 4 from that, let's see if this is true. 3 times 10 is 30. 30 minus 4 is 26. The absolute value of 26 is 26. Now, is this statement true? Is 26 greater than 9? Yes, 26 is greater than 9. Since x equals 10 led to a true statement, that means that x equals 10 is a solution. For this problem, you just have to find 3 solutions. So I already found one. You can try a couple more values and see how they work out. So if I were you, if I found x equals 10 was a solution, then my next one I would try is, I don't know, like x equals 9 and x equals 11, just close by values. So I'm not wasting a lot of time. Okay, let's do another. Number 9, use the polynomial function to answer this question. Okay, for this question it says one of the zeros on the graph is negative 4. Right away, I want you to underline this statement. One of the zeros on the graph is negative 4. That means that if negative 4 is a 0, that means x plus 4 is a factor. Okay? That's important to know. The question is now, what are the other two zeros of the function? So here's the thing. F of x, which is this big, wonderful polynomial, is really, if x plus 4 is a factor, that means it's one of the pieces that multiplies. So there are really two more pieces that multiply. And if I were to put them all together, they'll give me this big guy. Our job is to figure out what fills in here and here. So the way we'll do that is we're going to use synthetic division to figure out what these other pieces are. Well, if x plus 4 is a factor, if that binomial is a factor, I'll use synthetic division to see what the other factors are. Let's see what goes in the box. Would be negative 4. And then our coefficients of this polynomial are 1, 4, negative 4, and negative 16. So here's how synthetic division works. We bring down the first term, and then we multiply it with the box. So 1 times negative 4 is negative 4. And then we're going to add downwards. 4 minus 4 is 0. Again, multiply with the box. 0 times negative 4 is 0. And we add downwards. Negative 4 plus 0 is negative 4. Multiply with the box. Negative 4 times negative 4 is positive 16. And then add downwards. Negative 16 plus 16 is 0. Now I know I did this correctly because I got a remainder of 0. That makes sense because we already knew that x plus 4 is a factor. If it is a factor, that means when I divide, I should have no leftover. I should have no remainder because x plus 4 goes in evenly. So when I divide, there should be no leftover. So here's what I just discovered. I just discovered that our big polynomial over here is really just x plus 4 times, let's drop our power. It was a cubic function. That means our answer is going to be 1x squared plus 0x minus 4. I don't have to write 0x. This is really just x squared minus 4. I've rewritten this right over here. And you can even try it. If you FOIL this out, you will get this big polynomial again. But that's not really what the question wanted. The question wants to know what are the other zeros. Well, we already knew negative 4 was 0 because of this guy. Now my other zeros I'll get by setting x squared minus 4 equal to 0. Right? Basically setting this answer equals 0 and factoring. Here I have a difference of squares. X squared minus 4. X squared minus 4 equals 0. So if I set the first factor equal to 0, I get x equals 2. If I set the second factor equal to 0, I get x equals negative 2. And so these are my remaining zeros. X equals 2 and negative 2. So to recap, our steps are number 1. Use synthetic division to get a reduced polynomial. That would be this guy. When I say the reduced polynomial, I mean the one that you drop the power for. And then our step 2 is set that reduced polynomial equal to 0 and solve for x by factoring. All right, number 10 says find the inverse function. Okay, so we've got 2 steps to finding the inverse of any function. Step 1 is we're going to switch x and y. And step 2 is solve for y. The reason we're switching x and y is because, well, if I'm finding the inverse, that means that if I have multiplication and addition, I'm going to undo those, or I'm going to invert them using division and subtraction. And the easiest way to find the inverse is just by switching x and y, swapping their places, and undoing all of these operations. You'll see what I mean in just a second. Let's do part A. So A says f of x equals 2x plus 3. Step 1, switch x and y. Well, I'm looking at my function right now, and I don't see a y. So where is the y? Well, that's what f of x is. It's really y. So we'll cross that out and rewrite it. Now we'll swap them. So instead of y, I'm going to put an x. And instead of x, I'm putting the y in its place. Step 1, done. Now we got to do step 2, which is solve for y. That means get y all by itself. So we want to solve for y. I'm going to rewrite the equals x over here just because it's easier for my brain, and I suggest you do it too. It's easier for my brain to solve for something when that thing that I'm solving for is on the left side of the equal sign. Because now it's easier for me to see that I should subtract 3 on both sides. So I'll get 2y equals x minus 3. And then in the last step, to get y by itself, I just divide by 2. So y equals x minus 3 all over 2. And since this is my inverse function, I just need to remember in the last step to rewrite it as not y equals, but f inverse of x equals x minus 3 all over 2. Here, write that a little more neatly. Equals x minus 3 all over 2. There we go. Okay, let's do B then. So what you can see if you look at A, just to verify that we did this right, see how here we were multiplying by 2? Now we're dividing by 2. See how here we're adding 3? Now we're subtracting 3. So by switching x and y, we're basically trying to undo all of our operators. And so we get the inverse operators instead. Let's do B. So B says f of x equals 2/3 x plus 4. We want to switch our x and y first. So remember, this is our y. So to swap them, we're writing x equals 2/3 y plus 4. Next step, we need to solve for y, or get y all by itself. So first of all, I'm going to rewrite my equals x over here on the right side. And now this is where people make mistakes. There's 2 things to do right now. We have to get rid of this 2/3, but we also have to get rid of this plus 4. The first thing we should move is the 4. Whatever we're adding and subtracting is the easier thing to move. So if I have a plus 4, we're going to get rid of it by minusing 4 on both sides. We get 2/3 y equals x minus 4. Next step, we need to get rid of the 2/3. That's being multiplied with our y. So to get rid of a fraction, we just simply multiply both sides by the reciprocal. That means you flip the numerator and the denominator. If I want to get rid of a 2/3, all I have to do is multiply both sides by 3/2. Notice how I put the x minus 4 in parentheses. That's because when I multiply it by this 3/2, I want to make sure that I distribute it into both. So watch what happens on the left. 3/2 times 2/3. Now we multiply fractions by just multiplying straight across. That really gives me 6/6. Why? 6/6 is just 1. Why? So that undoes the fraction entirely. That's why we multiply by the reciprocal. So now I got y equals, now 3/2 times x is simply 3/2 x, but 3/2 times -4, I'll put that -4 over a 1, and over this on the side I'm going to multiply straight across. That gives me 3 times 4 is -12 over 2, which is -6. So 3/2 times -4 over 1 became -6. And that's important to distribute in the last step. Ooh, I forgot. I need to relabel. This y should be replaced with f inverse of x to show that we found the inverse function. And there we go. That's our final answer. Okay, so that was number 10. Let's look at number 11. It says, given this function, what is f of x minus h of x? So f of x is this guy right here. We're going to replace it. So let's write him down. 6x cubed minus 2x squared minus 7. And all it wants me to do is to subtract from that. So bring down the minus sign. I need to subtract h of x. Now h of x is this whole piece right here. To show that I'm going to subtract all of h of x, I need to put parentheses around it. Here's why. This minus sign needs to get distributed to every term. If you don't put parentheses, then the only thing you're actually going to subtract is this 2x cubed. But I want to subtract the whole expression. So that means all of my signs need to flip. So I'm distributing the negative. So first let me rewrite this. Okay, now let's distribute the negative. This is going to become minus 2x cubed. Okay. That's going to become negative 1 times negative 6x squared is plus 6x squared, and then plus 14. Now we'll combine our like terms. So we got 6x cubed minus 2x cubed is 4x cubed. We've got minus 2x squared plus 6x squared is plus 4x squared. Then we have minus 7 plus 14. That's going to be plus 7. And that's our answer. So it just wanted us to perform a simple subtraction problem. Well, subtraction, all you got to watch out for is put parentheses around the guy coming after the minus sign. That's the super important danger point, like watch out, common mistake. And then distribute the negative to all the terms. All right, number 12. It says find the quotient. Quotient is the answer from a division problem. So if it wants me to find the quotient of this and this, basically here's what I'm doing. Watch what I'm going to do. Cross out the word and that's what we're trying to find. What is this guy divided by x plus 3 over 2x minus 4? So see if you remember, when we're dividing rational expressions, we don't actually do division with fractions. We multiply by the reciprocal. Okay, my handwriting just gave up. Let me try that again. We're going to multiply by the reciprocal. The other way that teachers talk about this is drop, switch, flip. So to multiply by the reciprocal, we drop the first term. So we'll rewrite that as 3x squared over x squared plus x minus 6. We switch this into a multiplication, so times, and we flip the last guy. We take its reciprocal. So on top, I actually have 2x minus 4, and in the denominator, I'll have x plus 3. Hey, now this is a pretty straightforward multiplication problem. So when we're multiplying fractions, we multiply straight across, but we can factor and simplify first. We need to factor and simplify. Let's factor everything we can. Over here, we can do magic x. Over here, we can do GCF. So let's do that. We got 3x squared over. Now I need two numbers that multiply to negative 6 and add up to 1. So they're going to be 3 and negative 2. Yep, that works. So x plus 3, x minus 2. And we're multiplying that with, let's pull out the common term over here. I can pull out a 2 from both the 2 and the 4. I'm left with x minus 2. And that's all over x plus 3. So here's a question. Can this 3 cancel with this 3? If you said no, you'd be correct because this x plus 3 has a plus sign that acts like glue. It keeps this whole thing together. So put parentheses around it. It's one factor. Now, when we're multiplying, remember, anything, so to simplify, anything on the top can cancel with anything on the bottom. So you can cancel things up, down. You can also cancel things across, but it has to be one on the top and one on the bottom. So let's see what we can cross out. All right, I have an x minus 2 here that can cancel with that x minus 2. And oh my gosh, looks like that's it. So some people will be tempted to cancel this x plus 3 with this x plus 3. But these are both on the bottom, so they don't divide each other out. Actually, you multiply those because once you cancel your tops and bottoms, we finish the problem by multiplying straight across as always. So what I'm left with on top is 3x squared times 2, which is really 6x squared over. And on the bottom, I'm left with x plus 3 times x plus 3. So I could write that like this. X plus 3 whole squared, and that's our final answer. Okay, next. Okay, so now we actually do have a multiplication problem. We'll approach it the same way that we did with the last one. Basically, factor everything we can, and then simplify anything on top with anything on the bottom. All right, so let's do that. We do not need common denominators. That's only for adding and subtracting. So we're going to factor as much as we can. Ready? Let's do it. I have, this is already factored, so I'll just copy it down. Now down here, how can we factor that? Well, we can use GCF. I'll pull out a 2 and an r, and I'm left with r squared plus 8 times. Now this guy's already, like, we can't factor r squared plus 8, especially because it's a plus sign. Like if it was r squared minus 9, let's say, that's a difference of squares. That'd be r minus 3, r plus 3. But when you have something squared plus a number, like r squared plus 9, if you have something like this, that's not a difference of squares. That is a sum of squares. And sum of squares, this is a very important point, sum of squares do not factor. So it would be incorrect to say that's x minus 3x plus 3. No, because that's x squared minus 9. So just watch out when you have a sum of squares. Don't touch it. Okay, coming back to the problem though. We have r squared plus 8, which we can't factor, over. Now down here I can do GCF. Let's pull out a 2, and I'm left with r plus 2. So now we're looking, we can cancel anything on top with anything on the bottom, and then we'll multiply straight across. So here I have an r plus 2 with this r plus 2. One's on the top, one's on the bottom, so they go. I have this r plus 8 with this r plus 8, which is really in parentheses. One's on the top, one's on the bottom, so they can cancel. And finally, I have this 4 all by itself, and I've got a 2 over here. Well, I can cancel this 4 with this 2. I can also cancel that 4 with this 2. It doesn't really matter which one because both of them are factors. They're just pieces that are multiplying. So I'm just going to go ahead and cancel this out. That becomes a 2, that becomes a 1. So now what are we left with on top? Let's see, we're going to multiply straight across. Looks like we're only left with this 2 on the top. And on the bottom, I'm going to highlight what we're left with. So we have the 2 on top. On the bottom I have a 1 times r times 2. So 1 times r times 2, that's really just 2r. Hey, look at what we're left with, 2 over 2r. Well, that can simplify. 2 over 2 becomes 1 over 1, and my final answer is 1 over r. Oh my gosh, this is so important. Lots of times when kids are factoring, like let's say they have 3 over 3x, they'll cancel out the number, and since we're only left with an x, they'll mistakenly say the answer is x. But really, that x is in the denominator, so you need to make sure that when nothing is left up top, you're really always left with a 1. This would have been the correct simplification of 3 over 3x. So, coming back, our answer is 1 over r. Number 14, it says, find the solution to this quadratic equation. I knew it was a quadratic because it had an x squared. Here are our options. We can always try, well, since we have 3 terms, we know we can use magic x. But let's see if it works. I need 2 numbers that multiply to positive 6, and then that add up to negative 5. So those 2 numbers would be negative 2 and negative 3. Great. But we can't use our shortcut exactly because we have this number out in front, this 2. So the way we deal with that, with magic x, is we just divide both of our numbers by that 2 out in front. And we'll simplify. On the left side, negative 2 divided by 2 becomes negative 1. On the right side, negative 3 over 2 does not simplify, so you add an x into the denominator, like that. And now we can factor this. From here we get x minus 1 is one of our factors. And then for this guy that didn't simplify, we read it bottom to top. So that's going to be 2x, I'm reading the bottom, 2x, and then minus 3. And that's set equal to 0. So our solution then is going to be x equals 1 and x equals 3 over 2. Okay, I actually want to come back to this because on your final, there's a problem that looks like this, but it requires the quadratic formula. So I'm going to solve this now in a second way using the quadratic formula. So those are our answers. We know those are the right answers. But let's say they forced us to use the quadratic formula. You would only use that if magic x did not work, by the way. So here's our quadratic formula. You should memorize it or write it down on your note card. And to use it, we have to find what a equals 2, what b equals, which is negative 5, and c equals 3. So start by writing those out first, and now we'll plug them in. So x equals negative b. Well, if b is negative 5, negative b would be negative 5. It's awkward but important. So that's going to eventually end up being a positive 5, right? I'll just rewrite it right now. So that's negative b, okay, plus or minus square root of b squared. So negative 5 squared is 25, minus 4 times a, which is 2, times c, which is 3. This is all over 2 times a, which is 2. So now I'm going to rewrite this a little more neatly. X equals positive 5 plus or minus square root of 25. Okay, well, negative 4 times 2 times 3, that's going to end up being a negative number because there's just one minus sign. 4 times 2 is 8, and 8 times 3 is 24. And this is all over 2 times 2, which is 4. Next step is to simplify inside our radical sign. So we get x equals 5 plus or minus square root of 1 all over 4. Our next step is to simplify the square root of 1. Well, the square root of 1 is just 1, so that's pretty easy. I'm going to rewrite this as x equals 5 plus or minus 1 all over 4. And now I get to split this into 2 different terms. So I get 5 over 4 plus 1 over 4. That's one answer. And my other answer is going to be 5 over 4 minus 1 over 4. So I'm doing the plus version over here, and I'm doing the minus version over here, because remember it's plus or minus, so both of them are going to give us different answers. So 5/4 plus 1/4 gives me 6/4, which is really 3/2 when you simplify it. And then 5/4 minus 1/4 gives me 4/4, which is 1 when I simplify it. So we can verify that we know how to use the quadratic formula by comparing our answers here, 3/2 and 1, with our answers from up here from factoring, which were also 3/2 and 1. So we did a good job. I just wanted to make sure we practiced using the quadratic formula because it's on your final. All right, number 15. 15 gives us two complex numbers. Complex numbers just means that they have an imaginary part. There it is. There's an I here, and there's an I here. That's imaginary. So you need to remember I is equal to the square root of -1. Since we can't take the square root of a negative number, that's why it's imaginary. The other thing you should remember is that I squared always equals -1. Super important. Anytime you do I times itself, you replace that with -1. So let's do A. A says take Y, which is -2 plus I, and subtract from it X, which is this guy, 3 minus 4I. I need to make sure I subtract all of X, so I'm going to put parentheses, and then I'll put X afterwards. So similar to that problem we did earlier, we need to distribute this -1 here. And then we'll combine our like terms. So that's -2 plus I minus 3 plus 4I. Combining like terms, -2 minus 3 gives me -5. And then plus 1I plus 4I gives me plus 5I. And that's the answer to A. Let's do B now. B wants me to multiply X, which is 3 minus 4I, times that by Y, which is -2 plus I. So now that I'm multiplying them, now I actually FOIL. Over here, I just had to distribute the negative. I was just subtracting. There was no foiling involved. Here, because it's multiplication, that's when we FOIL. So make a note to yourself. We're only foiling for B. Okay, let's do this. I have 3 times -2, which is -6. 3 times I, which is plus 3I. Then I have -4I times -2. That's going to be plus 8I. Then I have -4I times positive 1I, which is minus 4I squared. Right away, immediately, two things should occur to you. First, we combine these like terms. And the second thing that you should notice is that we have this I squared. So that means we're going to replace that, remember, with -1 instead. So I'm going to combine my like terms right now. I'll bring down the -6 plus 11I, 3I plus 8I is 11I, minus 4, not times I squared, but times -1. So -4 times -1 actually ends up being positive 4. So let's finish this problem. I have -6 plus 11I plus 4. Combining my like terms in my final step, I'm going to get -6 plus 4 is -2 plus 11I. That is my final answer for B. So the key thing here was when you see I squared, you're replacing it with -1. So for example, you could have done this really in one step. Recognize that that's -1, and now -4 times -1 would have given us a positive 4. So you could have done that right away. Here's another one to try. Plus 8I squared. So I squared gives us -1. Positive 8 times -1 is really -8. It basically flips the sign, right? Okay, number 16, second to last, says, here's our polynomial function, and it's going to be divided by two different divisors to determine if they are factors. Okay, so for each expression, find the remainder. So to find a remainder, that means we have to do division. So we can actually use synthetic division to find our remainder. And then it says, determine if the binomial is a factor. So this is super important. If the binomial is a factor, that means that the remainder after dividing is equal to 0. So write this as a note to yourself. Remainder equals 0. If the remainder is 0, think about what that means. That means we've divided and we had no leftover. That means that it went evenly into it with no leftover. That makes it a factor. Okay? So what we're going to do is use synthetic division and check if the remainder is 0, then it's like, yes, it's a factor. If the remainder is not 0, no, it's not a factor. So let's start with A. We need to divide z of x by x plus 3. Using synthetic division, we set our divisor, the thing we're dividing by, equal to 0. I'm getting x equals -3, and that's what goes in my box. For synthetic division, we then take our coefficients, which are 1, +3, -4, and -12, and we place them right here. And as before, we'll bring down the first number, which is 1, multiply with the box. 1 times -3 is -3. 3 minus 3 is 0. 0 times -3 is 0. -4 plus 0 is -4. And then -4 times -3 is +12. Adding these downwards, we get 0. Oh my gosh, we got a remainder equal to 0. That's great. That means that, yes, x plus 3 is a factor. Cool. So 2 parts to this answer. The remainder, which is 0, we found that. And then secondly, yes or no. Yes, x plus 3 is a factor. Because when we divided, there was no leftovers. That means it multiplies evenly into our big polynomial. We'll do the same process with B, except the only change is instead of a -3 in the box, we're going to put a -4. We have the same coefficients though, 1, 3, -4, and -12. So let's do our synthetic division. Bring down the 1. 1 times -4 is -4. 3 minus 4 is -1. -1 times -4 is +4. Adding downwards, I get 0. And then 0 times -4 is 0. When we add downwards, we get -12. That last number is always our remainder. So here we got a remainder of -12. So we have a leftover. That means no. X plus 4 is not a factor of z of x, right, of z of x. Number 17 says graph the following equation. So in order to graph, see what we're dealing with here is a quadratic because it's got an x squared. That's the highest degree is a 2. So that means we're really dealing with a parabola. It's either going to face up or it's going to face down. Well, immediately we can tell it's facing up because it's a positive out in front of our x squared. So our leading term is positive. So I know my parabola is going to face up. I just don't know where it's hitting my axis. So the best way to do this problem immediately is to factor. Factor to find your x-intercepts. Let's do it. If I factor this, or rather, what I want to do is to find my x-intercepts. Let me rewrite this. Explain it in a different way. Find your x-intercepts. The way we always find our x-intercepts is set the whole function equal to 0. Right, so set the function equal to 0. Let's do that right now. X squared plus 8x plus 7 equals 0. So to solve, I need to factor. That explains it. I need to factor this. I need two numbers that multiply to 7, add up to 8. That's going to be 1 and 7. So this factors into x plus 1 times x plus 7, giving me two different x-intercepts at x equals -1 and x equals -7. So I'm going to go ahead and plot those. -1, 0 and -7, 0. And I know that this is facing up, again, because it's a positive in front of my leading term. But I believe that on your final, you're going to need to graph not only using x-intercepts, but the vertex. So while this gave us some x-intercepts to work with, and that's very good and handy, we also need to find our vertex. So let's talk about that really quick. To find your vertex from this, what we call standard form, since it's ax squared plus bx plus c, you simply need to find an x value and a y value, right? So here's how we find our x value. It's this simple formula, -b over 2a. And then to find our y, you just plug in x back into your original equation and solve for y. Let's do it in this for this problem. I've got y equals x squared plus 8x plus 7. So I need to find an x and a y for my vertex. Well, x is going to equal -b, which is -8, over 2 times a. A is 1 here, so 2 times 1. -8 over 2 is -4. So that goes into my x spot. To figure out my y value, I simply need to plug in -4 into all the spots for x. So y is going to equal -4 squared plus 8 times -4 plus 7. That gives me 16 minus 32 plus 7, which is -16 plus 7, which is -9. So I have my vertex at -4, -9. There we go. So now I've got a precise graph, and I know exactly how low it goes. Great. So there you have it. That is our entire second review. I hope it was helpful. Look at how much work we did. Oh my God, we are so good. All right, kill it on your final. Good luck.